be a good graphing review. 10 is... Alright, welcome to 1.1 homework help. Here we go. I'm going to do number 9 with ya. So these you have to say whether they're linear, exponential, or some other function, quadratic, which we talked about today. And then you have to find a recursive and an explicit equation. Okay, so first things first. Is it linear, exponential, or is it quadratic? From negative 17 to negative 12, I always like to check and see if it's linear first. I'm adding 5. From negative 12 to negative 7, I'm also adding 5. From negative 7 to negative 2, 5. And then from negative 2 to 3, I'm adding 5. Okay, so it is in fact linear. And then you're supposed to write down characteristics of how you know that. So I would say there's a constant rate, or it's increasing by 5 every time, or something like that. Okay, so then you have to write recursive and explicit. Recursive f of x equals f of x minus 1. Remember, this is always, sorry, hold on. I've been talking a lot today. Okay. Woo. This is always how we start out our recursive equations. Previous term, and then whatever we're doing to the previous term. So what are we doing to the previous term? We're adding 5. So that is your recursive equation. Boom, done, nailed it, moving on. Your explicit. When you think linear, you should always think of the equation y equals mx plus b. Always. Okay, that should pop into your head. So m equals your slope, b equals your y-intercept. So what's my slope? My slope is change in y over change in x. The change in y is 5. The change in x is, it's going up by 1 each time. This one, this one, this one, this one. So 5 over 1 is just 5. Because 5 divided by 1 is 5. All right. So y equals 5x. I just substituted 5 in for m, and then b is your y-intercept. So when x equals 0, what is y? They give it, they're nice. They give it to you in the table. When x equals 0, y is negative 7. Okay. If they didn't give it to you, you would multiply your slope times your x value and then figure out what you need to either add or subtract to get to y. So 5 multiplied by one of your x values, I'll do negative 2. 5 times negative 2 equals negative 10. But when x is negative 2, y is supposed to be negative 17. So I have to get negative 10 to negative 17. Subtract 7. Oh, look. Same thing. We'll do one more. 5. Ooh. 5. Oh, boy. 5 times. Let's do 0. Well, yeah, sure. 5 times 0 is 0. But when x equals 0, y is supposed to be negative 7. How do I get there? I subtract 7. Sorry, equals negative 17. Can you see that still? Yes. Okay. So that's how you could have figured it out. But they gave it to you. So we don't have to do this part. And that is all you need for D. Okay, then you have 9. This is E. They give you this table. All right, so you have to figure out, is it linear, exponential, or quadratic? Okay, Well, am I adding the same thing each time? 1/20th to 1/5. Okay. We're not adding the same thing each time. So then are we multiplying by the same thing each time? Well, 1/25th times what gives me 1/5? 5. Oh, 5. 1/5 times 5 gives me 1. 1 times 5 is 5. 5 times 5 is 25. If you don't believe me on the fraction, we can go over here. 1/25th, and we're going to multiply it by 5. Okay, so you can always put it, it's like right in the glare. Let me write it a little bit lower. 1/25th times 5. There we go. Okay. So you can always put your 5 over 1, multiply straight across. 5 times 5, 5 times 1 is 5. 21, geez. 25 times 1 is 25. And then you have to reduce. You can divide both by 5. 5 divided by 5 is 1. 25 divided by 5 is 5. So 1/5. Okay. So we're multiplying by 5 each time. So then for your recursive, f of x or f of n, whichever one you want to do, x minus 1, and then, so previous term, and then what are we doing? We're multiplying by 5. So that would be your recursive. Explicit. So for exponential, you should think of y equals a times b to the x. In class today, we talked about how to use the first term or the 0th term, which is the y-intercept. So if you use the y-intercept, when x equals 0, what is y? It's 1. So y equals 1. And then what are you multiplying by? What's your ratio? It's 5. Dx. You could leave it like that. Technically, you don't need to write the 1 because 1 times 5 to the x is just 5x. Okay. If you wanted to use the first term when x equals 1, you could. X equals 1, y is 5. Then you would have y equals the first term, which is 5. We're still multiplying by 5. But since you use the first term, it's x minus 1. So either one of those works. But that's your recursive. So recursive, and then any of these explicit equations works. Okay, oh, this is now f. All right. So they give you this table, quadratic, linear, or exponential. All right, well, you already can probably tell it looks a little funky because we have 2 of the same y values, which is fine, it's still a function, but we don't see that in linear or exponentials. But you can also go 9 minus 3 is 6, 6 minus 3 is not 5, so we're not subtracting 3, and we're not multiplying by the same thing each time, so it's probably going to be quadratic. But to test that, you find the first difference. You find the first difference. Okay, so from 9 to 6, that's negative 3, right? We're subtracting 3. From 6 to 5, subtracting 1. From 5 to 6, 1. And then from 6 to 9, 6 plus 3 is 9, so like that. Okay. If you have a quadratic, then your first difference will be linear. This is not linear. There was no constant rate here. We are not adding or subtracting by the same number each time. However, with our first difference, is this linear? Okay, so you do what's called the second difference. second difference. Okay. So from -3 to -1, what are we doing? That glare is so annoying. We're adding 2. Nope, it's just going to be right there. Okay, we're adding 2. And then from -1 to 1, we're adding 2. From 1 to 3, we're adding 2. Okay. So our first difference is in fact linear. We're going up by 2 each time. So remember, we're just looking at the red numbers. They're going up by 2 each time, so it is linear. -3 plus 2 is -1. -1 plus 2 is 1. 1 plus 2 is 3. They're going up by the same number. That means they're linear. So it is in fact quadratic. Hooray! Okay. So to write the recursive. I'm going to try to not write where the glare is. So f of x equals f of x minus 1, how we always start our recursives. Okay? But then it probably is helpful to make a table with your new, so now your new table is going to be your x values and your first difference numbers. So -2, nothing there. And then you have -1 and -3. And then you have, okay, this is 0, 1, 2. There, I rewrote my x values. So then 0 is with -1. 1 is with 1. Sorry, 1 is with 1, and then 2 is with 3. Okay, we're just ignoring the middle data for now. Okay. So we already said that our second difference is 2. That means the slope of this is 2, right? Our change in y is 2. Our change in x is just 1. So then m equals 2. Remember, now we're writing a y equals. We're writing a linear equation for this. M equals 2. And what's your y-intercept? Once again, they give it to you. They give it to you. When x equals 0, what's y? So it's y equals 2x minus 1. Beautiful. There it is. So you figure out the linear equation for your x values and the first difference. That's what this is. Okay. You ignore this for a second. All right. So then to finish writing your recursive, you just add. So the previous term is plus 2x minus 1. Oh, I'm a little bit too far over. Hold on. There we go. Okay. If you want to see how that works, I can show you real quick. If not, you can fast forward me. That's the beauty of the video. Okay. All right, so back to our regular table. I'm saying that this is the recursive equation for that table. So let's plug in x equals -2 and see if this works. Sorry, let's not do that. Let's pretend we don't know this. When x equals -1, we don't know what the y value is. All right, so you're going to go f. Actually, I'll move over more this way. F, and we're solving for -1, so plug in -1 everywhere you see an x. Equals f of -1 minus 1 plus 2 times -1 because there's an x there, and then minus 1. Woo! Okay. Then we simplify this. So f of -1 equals -1 minus 1 well, we'll just f of -2. -1 minus 1 is -2 plus, oh, actually 2 times -1 is -2 minus 1. We'll simplify that in a second. F of -1 equals, okay, f of -2. This is saying that x is equal to -2. What's y? When x is -2, y is 9. 9. And then rewrite everything else. -2 minus 1. Now we can simplify this side. 9 minus 2 is 7. Minus 1 is 6. And that was indeed our missing y value. So this equation works. All right, finishing up 9F. I just erased the board, rewrote some things. You have to do an explicit, which we haven't gone over. We will, obviously, but they kind of want you to try it on your own. So the form they're looking for it is y or f of x, whichever one you want, equals ax squared plus c, where c is a constant. Okay, it'll make sense when we do it. So since we've done all this work already, a is always going to be half of your second difference. So our second difference is 2, right? So a is half of that. Half of 2 is 1. So you have y equals 1x squared plus c. We still don't know c. So similar idea to when you're trying to figure out b for a linear equation. You're just going to go multiply your a. I was going to say your slope, but it's not a slope anymore. You're going to multiply whatever a is times your x values. So let's substitute in -2. So 1, substitute in -2 squared. So -2 times -2 is 4, times 1 is 4. But when x is -2, y is supposed to be 9. So how do I get from 4 to 9? I add 5. Oh, okay. We can try another one. So multiply. You don't have to write that you're multiplying by 1 because it's kind of redundant. Anything multiplied by 1 is just the other thing. So really you can just do x squared. So let's do -1. So -1 squared equals -1 times -1, which is +1. But when x is -1, y is supposed to be 6. How do I get from 1 to 6? I add 5. Okay, we can do one more. We'll do 0. 0 squared is just 0. But once again, when x is 0, y is supposed to be 5. Oops. So how do I get from 0 to 5? I add 5. Okay, so then you go back to your equation and you write plus 5. And you do not have to write the 1. You can, but you don't have to. Ta-da! Okay, so that's x squared plus 5. 10 wants you to graph. Well, they already gave you a table. So I would just graph the points they gave you in the table. So I'm graphing number 9. So this is 10D. All right. So I have a lot of negative numbers. I'm just gonna do doing that because I have more negatives. negative y's and positive y's, which is why I didn't draw it evenly. And then I have to get all the way down to negative 17. So I don't know, we'll go 2, negative 2, 4, 6, 8, 10, 12, 14, 16, 18. That's negative 2. That's negative 18. All right, and then this is positive 2, positive 4, positive 6. And then what, 1, 2, 3, 4. Negative 1, negative 2, negative 3, and so on. Okay. Hopefully you can see that enough. Okay. So you just graph the points I gave you. So, negative 2, negative 17. Negative 2, negative 17. So that's going to be in between. Right there. All right. Negative 1, negative 12, negative 1, negative 12. So negative 2, 4, 6, 8, 10, 12. Negative 2. My line is not going to be perfectly straight, but I'll try. And then 0, negative 7, 2, 4, 6, negative 7. 1, negative 2. That's like right there. And then 2, 3. 2, 3. All right. And then you would connect your dots. Let's see if I can make it look straight. Yeah. It'll be close. Ta-da! And that's all you do for, I think that's all they want, right? Is for you to graph them. Oh, you have to write your explicit equation above the graph. Okay. So this was y equals 5x minus 7. I mean, you can identify, no, that's all you have to do. Just know this is your y-intercept. So it crosses your x-axis somewhere, or your x-intercept is somewhere between 1 and 2. Okay, that's it. Okay, this is now 10E, graphing. You probably want to count by like 2s. I just counted by 1s on my scale, on my y scale. Okay, 1 all the way up to 25. Okay. Once again, you just graph the points they gave you. So negative 2 and 1/25. Jesus. So that's going to be really, really close to the line. And then same thing with negative 1. Be really close to the line. Can you even see that? No. They're very, very close to the x-axis, but they're not quite touching it, right? Because this is exponential. And then 0, 1. And then 1, 5. 1, 1, 2, 3, 4, 5. And then 2 and 25. Whoop. Okay, let's see. Draw my line. That was not the best drawing of a line, but it works. So it's continuing on forever in both directions. It's never going to touch the x-axis. It's just going to get incredibly close to it, and it's going up to infinity over here. All right. Oh, and then you would write your explicit equation above it. Okay. This, do we start? Yes. This is 10F. So now you're graphing your quadratic one. So once again, draw your graph. There are way more there are no negative x, there are no negative y values. So that's why I didn't even bother labeling down there. Okay? But you do have negative x values and positive x values. All right, so now just plotting the points. Negative 2 and 9. Negative 2, 9. Yeah. And then you have negative 1, 6. 1, 2, 3, 4, 5, 6. Negative 1, 6. And then 0, 5. 1, 2, 3, 4, 5. And then 1, 6. 1, 6. So it should be, so negative 1 and negative 1 and positive 1 both have 6 as their y. And then, is that all one? Oh, and then 2, 9. Ta-da! And now we're going to get a little parabola. So you connect the dots, which you should connect the dots. Once again, these are going on forever in that direction. Who brought it up today? Well, Alden. Sorry, Alden. Alden in my second period, fifth period, whatever you guys are calling it. So this is called a parabola. Parabola. It looks like a U. Call it a parabola. This is called the vertex. That's just good vocabulary to know. It's called, I'll write that better if you can actually read it. That'd be helpful. It's called the vertex. I'm sure I'll say that again tomorrow. But that's it. And then you would write your explicit equation above the graph. Okay, this is review. So it says identify the rate of change in each of the representations below. Rate of change equals slope. Rate of change. That just means slope. It's another way of saying slope. I don't know where the lit. Oh. Okay. So when you're looking at a graph, you can pick 2 points off the graph, but you can also just do it on the graph. So remember, slope is change in y over change in x. It's also rise over run. So I'm going to do this point and this point. All right. So that's 0, negative 3, and 1, 1. Okay, so you can either count it on the graph, or you can just do, okay, what's the change in y? So I'm going from negative 3 to 1. Negative 3 up to 1. 4. Negative 3 plus 4 is 1. Change in y is 4. Change in x from 0 to 1 is 1. 4 over 1 is just 4. So that would be your rate of change. Is 4. Or you can count it on the graph. So let's see. Rise, how much do I rise? So they're going by halves here, which is annoying. So this is like 2.5. This is 1.5. So I'm going 1, 2, 3. Oh, I skipped something. 1, 2, 3, 4. I'm going up 4. This is like if you drew in your slope triangles, right? So I'm going up 4. And then I go from 0 to 1, so that's over 1. So up 4 over 1. 4 over 1, which is just 4. And I think that's all I'm going to show you. Remember, you can also represent slope. So slope m equals y2 minus y1 over x2 minus x1. That's another way you can write out the slope. So if I was doing it with this problem, I would do, it doesn't matter which one you do as long as they match up. So I'm going to say that this is going to be x1, y1. This is going to be y2, and this is x2. Okay. So substitute them in. Y2 is 1 minus y1. Oh, I wrote that wrong. See, I need to be done for today. y2, x2. Okay. Anyway, but it's still y2, which is 1 minus negative 3 which just changed to plus, over x2, which is 1, minus 0. So you get 1 plus 3 is 4, over 1, which is 4. Okay, so you can also do it that way. All right, now I'm done. See you all tomorrow.